Question number 1 says a ball is thrown into the air with 100 joules of kinetic energy, which is transformed into gravitational potential energy at the top of its trajectory. When it returns to its original level, after encountering air resistance, its kinetic energy is A. 100 joules, B. more than 100 joules, C. less than 100 joules, D. not enough information. So with this problem, when you throw a ball into the air with a 100 joules of kinetic energy, and it reaches its top of its trajectory, on the way back down it encounters air resistance, which in turn would slow the ball down, even though it would slow the ball down from 100 joules of kinetic energy to less than 100 joules of kinetic energy. Therefore your answer is C. 4. The amount of potential energy possessed by an elevated object is equal to A. the power used to lift it, B. the distance it is lifted, C. the force needed to lift it, D. the work done in lifting it, or E. the value of the acceleration due to gravity. The correct answer would be D. the work done in lifting it. This is because if you take an object that weighs, say 100 newtons, and you lift it using 500 joules of force, it will possess that 500 joules of force in potential energy as you let go of it. 9. A job is done slowly. An identical job is done quickly. Both jobs require the same amount of work, but different amounts of A. energy, B. power, C. both A and B, D. none of the above. The correct answer would be B. power. So, say you have two identical objects, both 100 newtons. One is raised in 5.4 seconds, and the other is raised in 1.6 seconds. Now, since they're both the same, the amount of energy that you have to put into it is the same, but the amount of power that you have to put into it is different. In order to raise this in a slower amount of time, it would require much less power. In order to raise this object the same amount, or the same mass as this object, in 1.6 seconds requires a lot more power. 18. A small economy car and a limousine are pushed from rest across a parking lot, equal distances with equal forces. The car receives more kinetic energy is A. the limousine, B. the small economy car, or C. neither one. The answer is C. neither one, because even though you have a larger mass and a smaller mass, they were pushed with an equal distance of, say, 1 meter with an equal force of, say, 100 joules. 19. In order to solve this problem, you have a worker who is pushing a wheelbarrow with 40 newtons of force across a distance of 6 meters with an opposing frictional force of 24 newtons. In order to solve this, you would find the net force acted on the object, so that would be 40 minus 24, which equals 16. So the net force equals 16 newtons. Then you will multiply that times the distance. So 16 times 6 equals 96, which gives you your answer of D. 20. An object that has kinetic energy must have A. acceleration, B. a force applied to maintain it, C. momentum, D. none of the above. The answer is C. This is because potential energy is a weighting force, and kinetic energy is a moving force. So if you have a box, or a ball rather, up in the air, and it will have 100 joules of potential energy, let's just say, and then it is dropped, then those 100 joules of potential energy turn eventually into 100 joules of kinetic energy. In order to solve this equation, you would need two equations. The equation for kinetic energy, which equals 1/2 mass times velocity squared, and potential energy, which equals mass times gravity times height. We're going to start with this equation because we're solving for height. So the velocity, it said, is 15.0. So in the equation, 15.0 squared, the mass is unknown, times 1/2. So you take the square of 15.0, which is 225 meters per second, and then you would multiply it by the half to just get the mass by itself. And when you do that, you get 112.5 equals the mass. Okay, so now that we have the mass, we're going to plug it into this equation for potential energy, which equals mass, gravity, and we're solving for height. So 112.5 times 9.8 times h. So we're going to get h by itself by subtracting the h from both sides. So you have h equals 112.5 divided by 9.8, which would give you a height of 11.479, which rounded up equals 11.5, which gives you your answer of D.